Just the announcements of the day. Assignment 2, due midnight tonight. Drop dead is November 21st. Once again, as a reminder, what does that mean? You have full marks until midnight tonight, 10% off until Monday. Next Monday. After Monday, you get 0. Hybrids are due next Monday. Why? Because test 2 gets assigned on Monday. You got 3 days to do it. This week, you should be working on Lab 9. That's the announcements. Oh, one more announcement. I fixed the assignment 2 part 1 so that you can submit a second time or a third time. It's normally set to unlimited attempts. Some unknown reason it didn't take it when I hit the checkbox. So now it's set to unlimited attempts. I only grade the last one you submit, so make sure it's the good one. All right. Now, hopefully I don't have too much echo either in my audio stream since I'm using the built-in, whatever this is. It's a laptop. Every time I touch the table, it's going to click.
Hey, I've seen worse. My HP Pavilion, in addition to overheating really fast, microphone was crap.
Yeah, well, all laptops, microphones are crap. Okay, so what are we covering this week? I'm covering 3 topics. Which really it's a transition to the last couple of weeks of this course. After the first topic, which is views, you will have seen 95% of what's on the exam, the written exam. And then, so after views, there's going to be an introduction to database programming. So far, you've learned about designing a database, talking to a database. Now there's things you can do with the database so that things are automated. And we're going to learn about the automation side of it. Okay, views. Views is a method to store complex queries. In other words, and I always say this, I always prefix this, because my prof in college would have hated what the allusion I'm about to do now. It's sort of like a bookmark in your web browser. You got a bookmark that brings you to a web page. You can bookmark queries you use on a regular basis. It behaves just like a table for the most part. You can use it to filter and that kind of stuff. In other words, what's the word I'm looking for? You can just include it in a part of a join. You can use a where clause on it. For all intents and purposes, it behaves just like a normal table. It's just not very optimized. The syntax is as follows. As you can see down here, there's a complete select statement. And for those of you who have been doing labs, the select statement probably looks familiar. The only big difference is the first line up here. So you write your query until you get it working the way you want it to. Then just add create view with a name, as, in front of it, and poof. From there on out, you've got a view. After that, you could just go, in this case, select star from sales staff, and it'll execute this query for you every time. Therefore, you don't have to type up the big long versions of it. You can just take care of the short versions of it. Now, there's 2 kinds of views. Regular views. They're virtual only. That means that they are stored, what's the word I'm looking for? They basically, the definition is stored, but every single time you access it, you go select star from whatever the view is called. It scans all the tables that are involved, returns everything. So every single time you retrieve from a regular view, it pulls the data right away. The upside is the data is always fresh. The downside is it's going to eat performance depending how complicated the underlying queries are, depending on how complex the server is, that kind of stuff. The other kind is called a materialized view. Materialized views are when you create your view. So you go create view, but this one here is an option for materialized. It actually takes the results of that query and stores it in a cache. You guys know about caches, right? Roughly. Take the data, put it somewhere so it's accessed faster. What this does, materialized view will take the data you just created as part of the view and store it in a temporary spot. And every time you request from that view, it goes to the temporary spot, not to the main table scan. Why? Because it's faster, because it doesn't need to query everything else. It stores it based on whatever you had before. There's some real big perks. Obviously, they're going to be a lot faster because the database server doesn't need to scan all the tables again. It's using something that already exists, thus it's faster. However, it's not always up to date, because unless you run an update statement on, not an update command like that, but there's a command to update or refresh the view, then it rewrites the results of the view. A lot of systems set it up so that this runs at night, so it's part of an automated batch at night. It grinds and it grinds and it grinds and it writes it out to the disk every night so that the next day those views are quick. Often it's used for data warehousing so that you can store the results of the query as a file so that people writing reports go after the materialized views instead of the regular tables and things. You okay there?
Just saying.
Okay, Metal. Okay, Bike. And what happens with the BI, it stores in a set format so that the people writing reports don't need to understand the whole structure of the database. They just need to know this is the view they want to hit, and it runs it. Okay, you're at 95% of exam covered. Congratulations. Yay. Everybody have a coffee. All right. This is where, depending on the instructor, the focus of the course changes a little bit. Whereas the CT students, which are you guys, only get one required database course, I focus more on this stuff than, say, the people in CP, which get another 3 or 4 database courses. They get 3 more required. They get 2 more required no matter what, and I think they got a choice of 2 more on top of that. So you have the ability to program inside the database. As in, you could create your own functions, and by now you guys should know what a function is. It's from Java. And how you can create your own functions. Yeah, your own methods on a class, same thing. You can do the same thing with database servers. Well, at least modern ones. You can create your own functions that encapsulate certain functionality that you want. There's also the option for stored procedures, which is essentially, depending on the database server, there is no difference between a stored procedure and a function. In Postgres' case, they're exactly the same thing. It's just a matter of definition versus a definition as in the English definition, not the definition inside the database. Other database servers respect the difference between the two. Next slide, I cover the difference between them. And then there's triggers. And then triggers are for point-in-time activities. That I will be spending a fair amount of time on in the next couple of weeks, specifically the triggers. Now, different database servers offer different languages to write with. For example, Microsoft SQL Server uses a choice of 2 languages. The traditional one, which is known as Transact SQL, it's not on the slide, so don't look at the slide. You might as well look at me while I'm talking about this. Transact SQL or C#. C# showed up to the party about 5 years ago. The C# side of it is significantly more powerful than the Transact SQL, but it's also significantly more expensive in the sense that it has to call out to the runtimes and stuff outside the server. So it's a little more expensive. Oracle offers 2. They offer PL/SQL, Procedural Language SQL, and they offer, can anybody take a guess what the other language they offer? Is this coming from Oracle? Java. You can write your stored procedures in Java. Yay. Let's load up a heavy JVM on top of what we're trying to do every time. MySQL has 1 language. It's called Runtime. Real original. It's pretty limited. You can write this stuff in C on MySQL, but it's not recommended because it's not guaranteed it's going to work everywhere and all the time. Those are the common ones you'd see. Postgres, on the other hand, being open source and the most powerful open source database, decided they're going to do something completely different. They're going to give you the whole house and the kitchen sink. There are currently 4 common languages you can write in. There's PL/PGSQL. This one is 95% compatible to Oracle's. If you learn the PL/PGSQL, you've got a good grounding for Oracle's built-in language. They got PL/TCL, pretty much dead, but TCL used to be a scripting language back in the day. It was really popular. It's pretty much dead now, but it still has its place. There's PL/Perl. Some of you may have heard about Perl. It's an interesting language. If you're doing string processing, it's the best language, even now. By far, if you need to manipulate strings, that's the language you want to use. Then they got PL/Python. I'm sure you've heard of Python. Great first language, and it's a great language to write your database procedures in. Comes with some really nifty features, especially the Perl and the Python ones. It allows you to install them as trusted languages, which means you can get your database server to modify files on their disk. It can actually reach outside itself and manipulate the environment it operates in with those 2 languages. With Microsoft SQL Server, if you want to do that, it's nightmarish, and you can't do it with pretty much every other database server, so it gives it some uniqueness. All right. A moment ago, I said there's functions and stored procedures. In Postgres, they're essentially the same thing. But the difference that is generally accepted are as follows. A function returns a value. A procedure does not. Right? So you know in Java you create, hopefully this applies to Java, I know it's like this in C. If you create a function that returns void, it doesn't return anything. Whereas if it returns, I don't know, an int or an array or something, that's the difference between a function and a stored procedure. In the database server, one returns a value or something, the other one returns nothing. It runs, once it completes, it executes and exits, and it's done. It's, you guys are taking operating systems yet? No? Okay, when you take operating systems, you're going to learn about creating bash scripts. Same idea. A procedure is a set of commands, but so are functions. Essentially, functions and procedures are the same thing. You got a series of commands that you can make them do stuff. The other thing is a function should not alter the structure of the database. A stored procedure may alter the structure of the database. It's a definition thing. Postgres lets you do it either way. You can create a function that's a procedure, and procedures and functions the same thing in Postgres. In Microsoft SQL Server, they're not the same thing. Their stored procedures are sandboxed different than functions. In other words, you can access different parts of the database server. An example of why you'd use a stored procedure, cleaning out log files on a nightly basis, creating your materialized views, for example, on a nightly basis, all kinds of general maintenance stuff where maybe your database sometimes does get bad data. You create a stored procedure that crawls through the database server and cleans up all the bad data. So these are little jobs you'd like to automate. Functions, on the other hand, you'd use them to create, you could use them to generate PIN numbers. You could use them to generate passwords. You can use them to validate your information. If you want to get some really fancy rules for validation, you can create functions to do that. All right. And then there's triggers. Triggers is the last one. It's what they call event-driven actions. These are things that happen when other things happen. For example, anybody here ever opened the "do not open this door" alarm little sound door? Yeah, a few of you have done it. It's really embarrassing. Accidental, sure. Some of us have done it just because we want to see if it's actually going to go off. You know, different opinions on what you're supposed to do with that button. With that door. Well, there's a trigger on that door that says, if this door opens, sound alarm. Database servers have triggers. If certain events happen, do something. And most database servers offer at least 6 moments in time that you can capture. And in other words, there's 6 triggers you can tie into. Postgres actually offers 3 more, and Oracle offers about 10 more. Some of them are, if you create a table, do this. If you truncate a table, do this. Those are some of the other ones, but for 95% of the work out there, these 6 moments in time will cover everything you need. Now, what are the 3 parts of SQL that modify the data in your tables? Insert, update, and delete. So that's 3. And you can capture 3 moments in time, well, 2 moments in time, which is before or after, which means you can do before insert, before update, after update, before delete, after delete. That means you can write code. So if somebody goes to delete something, you can write code to go nuke all the orphans beforehand. Therefore, you can make sure that everything's going to run because you're cleaning out the database before the delete actually happens. Or maybe you want to log the fact that somebody went and deleted a record. Therefore, you can do an after delete. So once delete succeeds, you want to write a note somewhere saying, you know, Bicycle went and erased records out of the database today. You're going to get picked on today. All right. Depending on the database server, the trigger may or may not be part of a transaction. I'll give you the short version of the word transaction now, because I cover that in more detail later in the course. A transaction is a set of operations. With Postgres, the moment you issue the insert statement to the moment the server returns success is a transaction. That means that if you have a trigger that fails, the insert won't run. Some of you have already experienced this, right? When you're writing all those commands at once, and then you do a create table, and there's an error, so it doesn't run the other ones after it. And even if the first 3 run correctly, and then the last one fails, they all fail. That's a transaction. It treats that as a single transaction. Postgres, Oracle, Microsoft SQL Server, triggers are part of the transaction. That means things that are happening as part of that moment in time stay self-contained until it's done, and then it gets applied. All right. Trigger flow and the available data. So I'm just covering the theory today. I'm going to do a simple example of a function for you guys, because the triggers I'm covering a big example next week. The trigger flow is a specific series of events that happen, and depending on what is happening, there's 2 data structures that may or may not be available to you. There's the new and the old. When a trigger is fired off, automatically the database server creates a record in memory, let's call it. You guys haven't learned about arrays yet, have you? No. Yeah, okay. Well, you're going to learn about arrays now. Sort of. Now, it creates 2 objects in memory, one called new, one called old. The new contains the data that's being currently pushed to the database. The old contains what was there before. And there's 3 sets of commands that go with it. So I already identified that we have insert, update, and delete. Okay, by the way, the new and the old, the keywords, are case sensitive. Uppercase old, lowercase old is different. So when you do an insert, for example, You have access to new, but you don't have old. Somebody want to take a guess why you wouldn't have access to old data when you're doing an insert? Think about it for a second. Eh? It inserts new data, yes, but why is there not access to old data when you insert new data? No, there's no old data. It doesn't exist. There's nothing there before. When you're adding something, there's nothing there before. I'll go back to my house building example. You built a house. There's an empty foundation. You're going to build a house. Is there a house there before you built the house? No. Therefore, there's no old data. Now, when you do the update, though, you have access to both. Why? The new data that you're pushing into the database, in other words, you're updating somebody's email address. That's the new data. You have access to the old data, which is the old email address. Why would you want that functionality? So that you can compare what was there to what is there now. In other words, what was there before, so you can see while they're updating their record, are they changing their email address, yes or no? Is it the same email address? You can do checks like that with the trigger. It allows you to do some logic checks against the old record. And then when you do the delete, you only have access to the old data. I'll ask this again. Why do you only have access to the old data when you're doing a delete? There's nothing new. Because you're not creating something new. You're not changing something that exists. You're getting rid of something. Right? Picture insert as in you're building a new house. Update, you're renovating your house, right? What was there before? Well, what are you putting into the house? What's there before? In other words, new doors, old doors. Then the delete, you can think of it as demolition. Obviously, you're taking out a house. You're not adding a new house. You're just destroying the house, which already exists. So if you want real-world physical examples of how you can visualize this, that's what it is. Those are the bits and pieces. When I get into the detail of the triggers next week, you'll actually see how it works. But today I'm trying to get the theory out of the way. All right, my trigger flow. I'm going to upload this particular diagram to Blackboard so it's bright, it's bigger. It actually looks not half bad on the screen. This is the process. As you can see, this is the standard flow chart, but I put in all kinds of colors on it. Basically put, the SQL interpreter is what they call an interpreted language. The server receives the command. It reads the commands and sees what it needs to do. And then it starts doing determinations. It's going to be back in a second. NVIDIA cards on laptops. Sorry, NVIDIA cards in Windows 10. Now, command receives. Is it a manipulation command? Is it an insert, update, or delete? Yes or no? If not, what happens? The SQL server will take it, parse it, and run it through. Boom, it's done. Then what it does is it says, well, is it a manipulation command? Yes or no? Okay, yeah, it's an insert, or it's an update. What it does, it checks to make sure the command is valid, as in, is the insert statement correct? I'm sure you guys have experienced it by now, trying to create an insert statement that's not correct. And the server tells you, dude, go check your syntax. Then, if it doesn't parse, it raises an error, goes to the red box, and returns the fact that an error happened to the client. And then it checks, is there a before trigger? So before it even runs the command, it says, is there something that's supposed to happen before I do this? Yes or no? If there is, it runs the trigger. And if it succeeds, it continues. If there's no trigger, it just goes on to the point where it applies it to the database. It executes the command. Did it succeed? Yes or no? Obviously, no. There's an error. Yes, it continues. Then it goes, hey, I successfully wrote the data into the database. Is there an after trigger? Is there something supposed to happen after they've done this? Yes or no? Again, it executes it if yes. If not, it just continues on and exits. So every single time you run an insert statement or an update statement, the database server does this. I'm simplifying it here, but this is basically the process of what happens every single time you run a trigger. And yeah, that's pretty much it. That's all there is that happens when you do it. Now, normally at this point, I wish I had a piece of paper. Anybody here got a blank piece of paper they can throw at me? Doesn't need to be fancy. I don't care if it's even ripped. I just don't have anything in my bag. Anything, just one. Okay. We're going to play physical side of it. Okay? I'm the database server. And the way it's going to work is I'm going to need a couple of people all in one process. And what's going to happen is we're going to create a before trigger. I'm going to be the database processor, and we're going to have an after trigger, and we're going to have the person issuing the command. So what I'm going to do is I'm going to say, dude with the Toshiba on the corner here, who's not looking at me at the moment, okay, you're going to send me a command. I'll tell you what to do in a second. You're going to be my before trigger. You're going to be my after trigger. Okay? I'll be the database processor. So all you're going to say is you're going to give me a word. Not yet. When I ask the before trigger, what am I supposed to do? You're going to change the word to something else. Because I got to spell it. And then you're going to be the after trigger. And then you'll understand why some of this stuff works the way it does when I finish the explanation. So give me a word. Just a simple word. Big word. Board. Good, thanks. I appreciate that. Okay, now I'm going to go, oh, I received a command, board. And exam's going to change it to something else. But you notice, I haven't written it down on my piece of paper yet. Right? I haven't written it down yet. Give me another word. They're replacing the word board with something else.
Does it have to be like a long
Just, no, I don't care. It's a word.
Happy.
Good. So what I'm doing now is I'm going to put down the word happy on my piece of paper. After trigger, try to change the word. No. Try to change. You change it to happy. I just wrote it to the database. It's now been physically applied to the database.
What do you mean by change it?
Just try to change it to something else.
Oh, just another
change.
name?
Yeah, create another name.
John.
No, you're not allowed to. I wrote it down.
Oh, okay.
Okay? Before, when you write a trigger that runs before, you can change the data.
Wow.
When you write a trigger that happens after, and it's been applied to the database, guess what you can't do? You can't change the data, sorry. I'm trying to explain. Keep over. So, I like using the paper example as to explain the immutability of the data once this step here happens. When it goes execute command right here, the data is now immutable. You can make changes all you want to the data. Nothing's going to happen because it's been applied. It's as if it's written in stone. You can use the new data to change the data that's being written before you write it. Once it's been written, you can't change it. You can make all the changes you want, but you cannot change it. That's just how it works. Okay, as I said, today's a lot of basic concepts in theory. What's going to happen in a minute is I'll create a basic function that does something, so you can see what the language roughly looks like. And it's going to suck because I'm typing on a machine that's actually got the microphone on it. It's going to be great for anybody who's watching this later. And then what's going to happen is, well, essentially, I'll be defining the bits and pieces of language that you should recognize. So this is the definition of a language. Anybody here ever see a language called Pascal? Okay, you've heard of it. You nodded. Pascal has an interesting functionality to it. Every piece of Pascal that you write has a declaration of variables at the top. For example, you know how in Java you can define a variable anywhere you want? You know, new something, there you go, you know, new something equals new whatever. and bang, you got a new variable on the fly. I know Java so well, right? That was a great example. New something's equal to new something else, right? But, or I could use the PHP example where I can go $name equals Dan. Bang, I create a new variable on the fly. With Pascal, you're not allowed to create a variable anywhere you want. You have to declare it at the top of the program. Every single variable you're going to use has to be declared at the top. Postgres functions and triggers are the same. Essentially, you declare everything you're going to use inside of it at the top, and then you can use it to your heart's content, but you have to declare it before you can use it. It takes people that are used to languages like Java and C a little time to get used to it. Those of us that have played with Pascal, COBOL, Progress, insert language here, mostly, if you notice, those are 4th generation languages I've listed off. They like their declarations at the top because, for 2 reasons. It optimizes the compiler because it doesn't have to guess, it makes compile times faster. And it also enforces the usage of the variables, so therefore it makes sure that everything's declared properly at the top with the right data types. It's just how it works. All right. Now, defining a function, and triggers and functions have a lot related to each other. Next week I'll cover how they're done in Postgres, the trigger side of it. But when you define a function, there's a bit of syntax. There's the create function command. You know, you've done create table, you've done, create a few other things, and you can create that. Then you give it a name. Then there's some arguments with the data type that's applicable and defaults. It sounds familiar, right? It probably sounds a lot like something like that. Not quite the right syntax for Java, but you get the idea. And then you define the return type also. Then you define the variables in the code. You return a value. Then you exit. There's a few important things. And this slide you'll probably want to remember. So like I said, I'll be posting this slideshow to Blackboard, so you have this slide. I'll be using PL/PGSQL for all the trigger examples and the function examples in this class. Why? Because I could go with 4 different languages, and I'm just going to keep muddying the waters if I say, oh, this one I'll write in Python, this one I'll write in Perl, this one I'll write in PL/SQL. It's pointless to mix and match the languages. I'm going to stick to PL/PGSQL. PL/PGSQL is what they call a single-purpose programming language, and it's self-complete. That means that everything it offers for you to use, you can use, but you can't bring anything external into it. In other words, you can't include a library from something else inside that function. It is inside that language because the language is complete unto itself. This is the one that trips everybody up. Assignment of values uses colon equals. So if I want to assign a variable, it's something like this. This is going to trip up all you Java guys. I guarantee it. I guarantee in lab I'll have at least half the class coming up to you going, I'm getting an error here. Why? Can anybody take a guess? This is a real thing, a moment's trivia here. Can anybody guess why they decided to go with colon equals?
So usually when you create something, please enter integer will create 2 colons.
No, nice try though. It's a good guess. It has nothing to do with usage. Anybody else want to take a guess?
Assignment?
Eh?
Assignment?
Well, it's assigning, but why did they choose that combination? Because in the language of SQL, the equal sign is already defined. It's the equality operator. So therefore, we can't have language say name equal than, and then go if name equal then you can't use the same operator twice. I know my handwriting just fell to pieces at the end there. But the assignment of the equal sign was already used. It's the assignment operator. How do they avoid that in C-like languages? Equal, equal. So they use two equal signs glued together. SQL was being created roughly at the same time as C was. And they already had equal as the equality operator, therefore they had to come up with something different. And obviously doing equal equal to a sign sounded kind of stupid in its own little way, because people get confused, so they came up with colon equals. At least in this particular line. Other languages use a different syntax, but essentially they all have their own quirky little way of assigning values. And in Postgres, it's colon equals. Instructions are semicolon terminated. This should feel comfortable for you guys. It's just like Java. It has conditionals. Howard tells me you guys should know what conditionals are. If, else if. Okay. The syntax is a little different. It looks somewhere between half Pascal, half BASIC. Has anybody in here ever seen BASIC other than me? 1, 2. Yay. 3. Yeah. It looks like if, whatever, then. The language looks exactly like Pascal and BASIC for that. It also has for loops and while loops. So if you know your loops, the syntax is different, but the concept works exactly the same. I do have a link on the slide that points you to the syntax reference for this language. And we're talking, there's a ton of reference. If I remember right, last time I checked, the language reference for PL and PGSQL was about 75 pages long of different things you can do with the language. I am just setting something up here. There we go. I wanted to be able to actually read what I was doing. Hi. This is a database you guys don't have, but I'm just using this as my example. Okay, I've got in here a very simple, let me move the lectern. Simple database that has stuff in it. Now, when I'm working with triggers later on, I'll be using this particular database example because it's really simple. It's only got 2 fields. But I'm going to create myself a function right now that's going to generate a string. Actually, I'm going to create a function that's going to truncate my strings for me every single time. Why? Why not? Or, yeah, we'll go with that. So, as I said earlier, the language is interesting because it allows you to create functions. I'm going to create a function, so it's create function, like such. Then you give it a name. So, I'll call this, there you go, make username. And it's going to take a varchar as its argument. And why am I putting curlies? I have no idea. Alright, so here's the first part. I'm going to turn this a little bit so that it catches a little bit what I'm pointing at. So we have create function. That's the first little bit at the top. And remember earlier when I was discussing, and that was a stupid place to click. And not that either. I've lost control of my mouse. So we have create function. In the previous slide I discussed, the first part of creating a function is you call create function. Then you give it a name, and then its arguments, types. So this one takes one argument, and it's a varchar. And then it returns a varchar and as. This is where basically put at this point we start defining the function. So we gave it a name, we told it what kind of argument it's going to take, and it's also going to take, return a piece of text. Then we define as. Now this is where we have to add something in, because we have to now tell it everything you see in here is code. Because what's the typical instruction terminator in SQL? Semicolon. Right? And what happens every time the interpreter sees the semicolon? It sees that as a command that needs to be run. Well, what happens when you're defining your function is that you have multiple commands you might want to run that are all ending in semicolons. So the interpreter needs to know that everything between this, don't do it right away, do it later. So you define it using a series of tags. And it helps if you write them the same way. So I created two tags called body. Everything I put in between those two tags will now be treated as something to be executed later. And then we have one last step at the end. I can't type today if... The language statement at the end tells the interpreter what language is being used inside the body tags. So if I was using Python, this would be PL Python, for example. So I could write Python in here. Or if I was using Perl, I could use Perl in here. But since I defined it as PLPGSQL, what is it going to return? It's going to interpret it as PLPGSQL. That's the language it's going to use. Now, arguments that get passed in as, and this is actually challenging because you guys haven't taken bash scripting. Usually my students have taken bash scripting by now. Each argument that gets passed in gets assigned to a variable, and it's $1 is the first argument. If I had two arguments, it'd be $2, $3, $4. So I'm putting in a comment in here so that you guys have that for future reference. Okay. Now, if I go, I was just double checking the syntax of something. Let's say I want to return, so let's say I'm only allowing 6 characters for the username. What I can do is go I lost my screen. There we go. Okay, it looks kind of weird syntax. But essentially what it's going to do is going to return a substring of 1 for the first 5 characters from character 1 to 5. And let's see if I actually wrote this properly. And I got an error message. That is so annoying. Sounds like the building's falling apart, that's for sure. I keep clicking on the wrong window. Okay. So this returns a varchar. And actually that should just work the way it is. Go figure, it's not going to cooperate. Alright, well I'm going to assign it to a variable then. Well, that goes inside the body. Oh, damn. Let's hope I stop clicking on the wrong window. Alright, that worked a little better. Alright, I made it more complicated than I wanted to as my first example, but that's fine. Now, as you can see in here, I created a variable. Remember a few minutes ago I talked about how you have to declare your variables before you can use them? I declared a variable. This variable holds a varchar. As you can see, I didn't define the length of the varchar. It just means that it'll take any size of varchar from 1 to the maximum size of varchar. So if you don't define the size, it lets you work with it as you want. I have a begin and an end. Once you start using things like declare, you then need begin and end so that it knows the difference between what's being executed and what's being declared. I'm assigning a substring of whatever the argument gets passed in, it's basically from character 1 to 5, then I return it. Now, the way my code's been going lately, I wonder how well this is going to work. So obviously I just fed it something that's more than 4 or 5 characters. Let's see what happens when I run it. There's my 5 characters. I created a function that truncates a string. In theory, I could get really fancy. In a lot of places, the usernames get created automatically based on a script. And I could actually, let's say I want 2. What's the wrong word? I want you to pass in the first name and the last name, and then return a username that has been built from that. I could do something that looks like this. Now, in Postgres, you guys know about concatenation? Concatenate? I don't know. I remember what it is in Java. I think it's plus. String plus another string equals, a bigger string. Does that ring a bell? Yeah? Vaguely? Okay. In Postgres, the first mistake everybody comes in from a language like Java or C makes is they go, oh, concatenation, that's the plus sign. No, it's not. Sorry to tell you it's not. There's 2 ways of doing it. Postgres has one. It has the short form concatenation operator, and it's double pipe. And let's just say I decide that my username rule will be as follows. Because those of you who have had the experience here already, right, where you've got your last name, maybe part of your first name if you're lucky, and a bunch of digits is your username here. Like for example, where I work, our usernames are our first name and their first initial of the last name. Other places, it's the first name, first initial. So what I'm going to do is I'm going to make this be the rule that it's their first name, first initial, plus their last name. So if I change my arguments to be like this, and now there's my new username. There's one last thing we should be doing at this point. Some servers care about the case of the name. Did you notice I was passing everything in uppercase? One of the things you should do. And that is not right. That was PHP. And if I run this, and now I got a lowercase username from stuff that's being passed in uppercase. I'll be posting this example to Blackboard. And I'm going to be commenting it. And I'm actually going to create the comments right now so that you hear the logic behind what's happening. All right. Okay. Now, I'm declaring a variable. And I'm declaring one variable. Because I only need the one variable, the variable that's being returned. Well, PLPGSQL is known as a code block language. It's a block language. We're a block language. You define blocks of code that get executed. And you can actually have multiple begins and ends. And you can give them names. That's way above the pay grade of this course. But you can define sections, and you can actually do jumps between the sections. Those of us that have played with BASIC probably remember the goto command. Goto was horrifying, but it had its place in the world. So you can restart a code block with begin. So those are the two arguments that are being passed in. As you can see, this would be $1, that's $2. It's place-based, so each argument gets a number that goes with it. Now, so we're going to build our username from the first character of $1 and the full second argument, which is $2, and lastly we're going to force all shooting match down to lowercase. And it's all done in one line. Theoretically, I could do this as multiple steps if I wanted to, where I could go declare first character, declare last name, declare concatenated name. You could just declare all these variables and build them up. There's advantages and disadvantages to that, because for every variable you define, you occupy some memory. Therefore, unless you know specifically, it's a car1 plus a with this and a plus of that, it's going to be a problem. And then we have one last thing. return our value. Okay, just like in Java. And then we end our code block. And quit. That is what's happening inside of that function. And inside this example, I've covered how to declare a function, how to declare arguments, how to declare the data type return. We created created a variable. We began our code. We did something, right? We created a return value. We assigned it. We returned the value. Then we ended the program. This should sound familiar to writing a basic console-based Java program, right? You create your function main. Stuff happens. Program exits. You know, you type in 10 numbers, find the biggest, you know, just like Howard had on the screen. I could do the same thing with this, actually, technically, if I wanted to. I could pass in 10 numbers and find the biggest one. It could be done also in this if you wanted to. I don't know why you'd want to, but you could. It'd be very inefficient. But other than that, that's essentially functions. And I am going to actually cut the lecture off early today. Why? Because I don't want to give your brains too much more to process before the test next week. You should be working on Lab 9. By next week, I should have my camera back, so there won't be as much clicking in the recording. That's the secondary reason why I'm killing it off for now. I'll see whoever's in lab after this. If you have any questions, feel free to approach. I've got half an hour to kill.